So, glad you could join my presentation. Unfortunately not in German. I studied German on mid-school, but it was there, and well, I don't use it a lot. I can speak a little bit, but not for this presentation, so I'll do it in English. Welcome to my presentation. I arrived yesterday in Nuremberg by train. It was very comfortable, so I had a good journey. I first considered to take the plane, but I thought no. With this environmental conference in Glasgow, I'll take the train. So, thank you. I haven't done anything yet. Let me introduce myself a little bit. I've made a timeline for myself. Born in 1966, kindergarten, high school, mid-school, everything. I studied clinical pharmacology and applied some jobs in the Army, in the Royal Air Force, and later on in the industries. Big pharma is also a topic these days, of course, but at that day I worked at a pharmaceutical company, and later on I worked in a hospital, clinical pharmacy, and in that time I also more or less switched to IT, because there was a system, a very ancient one with terminals and based on Unix already. That was maybe modern for those days, but it was based on terminal access and a lot of code, and was very bad support on it, so I dove into it and learned myself Unix and some bit SQL with kind of a mumps language which was there. So in that time I switched to IT in around 2000. And from then on, you can see it went back downwards with me, looking at my face. But yeah, I still work in IT for more than 20 years, and I've saw a lot of projects, a lot of things, a lot of customers. And when I applied for this conference, my paper, I was more or less surprised that it was accepted, because open source, enterprise, don't know if that matches, but I just thought let's try it, and I was accepted. So so I thought I'm going to tell something about my experiences with a commercial product like Oracle, of course, has in combination with open source monitoring. If you usually buy Oracle stuff, then you get something extra, but you have to pay for that extra as well. It costs licenses, and for my customers, I also try to achieve to do it as cheap as possible, but still in a good way. And now you can think of building something can be also expensive. You have to hire engineers to build it. It takes maybe a year or two, and then you have something maybe which doesn't work, or maybe works partially. So it's a bit of what do you choose. But if you choose for Oracle products, for instance, or other product from another vendor, it also needs configuration and maintainability. So my topics for today is I'm going to talk a little bit about the challenges you have around visibility. Observability is the new word which I see. Every company wants an observability engineer to watch all these things happening in application landscape and in infrastructure and everything. I'm also going to talk a little bit about Java Enterprise and application servers, like a bit of the old world. In an ideal world, every customer has modernized their infrastructure and their applications, but in the real world, it's not there. There are a lot of customers have a lot of legacy and invest a lot of money in building those legacy products. And for example, I worked for a government organization which has a large HRM system built in Siebel, and they now already said for 10 years we have to modernize from Siebel into something new with microservices and everything, and it will take another 10 years before they are there, I suppose, I guess. So a lot of companies will remain using legacy in combination with new stuff, and this is a bit where I come in and say, well, we have something for you which maybe can help you with that transition. And also a lot of big tech companies like Oracle, like IBM, are also diving into that area. I mean, a lot of companies at the moment, like IBM, like Oracle, or Red Hat, are all active in the open source community as well, to build open source stuff for customers, and to also join, ask developers to join their community. Also for them to actually gain more revenue for their products, because if you have this customer on open source, then you can also get him on your product, what you have. So it's very smart of them, of course. And also a bit of about the Java application server on Kubernetes implementation, because that's also a thing which a lot of companies are struggling with. I heard everyone is containerizing. Everyone does Kubernetes. I have to do it too. First of all, you need to consider what you are doing and why you're doing it. But if you are deciding to do it, then this is a path to go, maybe. Not the end game, of course, the end story, because still you have a Java application server running in a container, but it's maybe a transition to maybe more modernizing your applications as well. Talk a little bit about operators, and of course where you already all come from is for monitoring, how to monitor these stacks. So you have this complexity in IT world these days, a lot of platforms, different platforms, and every big vendor wants to move you to the cloud. I don't know how it's in Germany with cloud. In the Netherlands, there are some companies which are very, like Rabobank, they are aiming on cloud, but there are also traditional ones who say, well, we don't do it. Governments, for instance, or they do private cloud, but they don't want to have commercial cloud, for instance. So it's a bit of, I think 70-30, 70% no cloud or some cloud, and 30% who are more cloud, agnostic. Don't know if you say that way. Of course, a lot of applications these days as well, application technologies. So how are you going to monitor these? Because this all ends up into a production live environment with engineers, usually operators or so, who are not, they don't know anything about all these applications and all these languages. They just need to know, is the application up? Yes. Is it down? Started? Is there some issue? Solve it, or maybe some other way. If you do DevOps, it's maybe a complete other story, but also with DevOps, I see just a few companies who are trying to do this, but a lot of companies are still traditional with silos, with a development team, a test team, and an operations team separate. So if you have an application, you have an infrastructure, there's a lot of data in it, everyone knows. The application data, of course, but also a lot of non-functional data. And I know some customers are very reluctant to say, well, skip it all, throw it away, it's not useful. But you can also think of, how can I use this non-functional data, like metadata, log data, runtime data, statistics. Maybe I can use it to predict something in the future on my application or my application stack. So to getting operational control and to say, you probably heard about proactive monitoring, for instance, like also already knowing what's going to happen. So first of all, it's the customer who calls, it's broken. Second one, you know it's broken, or you can say to the customer, it's still working, because you were proactive and already acting on what's maybe might be expected, like capacity planning. If storage runs out, you want to know it in front and not afterwards. If someone does an installation and it generates a lot of log files and the storage is completely full, then it breaks, your application breaks. You also want to know maybe what end users experience. There are a lot of synthetic monitoring systems who can monitor URL paths for users, what they click on, their click path. This is also a part of what you want to know with monitoring, especially when you have a web portal maybe running. You want to know what the customer is experiencing. I had a customer who was a healthcare insurance, which is now in the Netherlands. It's the critical month for them because they are now deciding what kind of tariff you have to pay for your healthcare every month. So they try to get as many customers giving a lot of discounts at a time. So the systems should be running. So they also want to know if a customer goes to their website, clicks on something, and tries to create a policy for them. Then they want to know what goes wrong if they get an error. So they want to see a trend analysis on that as well. So there are a lot of tool stacks to monitor, of course. The usual suspects you see here, Nagios from Microsoft, SCOM, also the open source stuff. Oracle has its own monitoring stack as well. Splunk, of course, you know them all. But for this session, of course, I'm going to talk a little bit about Grafana, Prometheus, Kibana, Logstash. And I consider myself not as an expert on these platforms, more like a user or a super user. I think there are a lot of people in here who know a lot more about how to use it and how to build it. But from my perspective, I try to talk a little bit about how I implemented it into a traditional Java application server running in Kubernetes. First of all, a little bit explaining about which Java application server I mean. It's WebLogic, and WebLogic is a Java-based application server which is running on a Java virtual machine. And a Java virtual machine is actually a container which takes care of all the code of Java code in the most efficient way. So you have open source JVMs or Oracle JVMs. Oracle donated everything to the open source community under the name of Jakarta EE. But still, you can also use the standard Oracle JDK, for instance. On top of that, there is a caching system, coherence, for caching in your distributed systems. And on top of that, WebLogic server. And on sides of that, you have development tools like Eclipse or JDeveloper and some stuff to monitor with which they call Enterprise Manager. These are all proprietary products from Oracle, actually. And on top of that, WebLogic was acquired by Oracle in 1998. Then at that time it was from BEA, and from then on it was not only a Java EE application server anymore, but all the products Oracle had, they dumped it on Oracle WebLogic server. So, yeah. So these are some kind of the building blocks which I used, or Oracle uses also, because a side step. I once saw a presentation of Kelsey Hightower at Puppet conference, was it, I think? And they talked about Kubernetes and how it would fit into the Puppet world. And then he mentioned the enterprise, like Oracle, and then he switched over to the Oracle database because the database is the most well-known product of Oracle. But now it's for me it's not that I want to stand up for Oracle, but Oracle does a lot more at the moment than only Oracle database. They're active in the open community, open source community as well. And what they did is they ported Oracle WebLogic into a containerized platform. And this is because a lot of customers are, as I mentioned already, struggling with how should I handle my infrastructure? Should I still stay on virtual machines or on bare metal maybe? Or can I modernize it to use it in containers? So Oracle, also part of CNCF Foundation, also started developing technologies for WebLogic to lift and shift your entire application server platform into a containerized, orchestrated platform with Docker containers or other containers, not only Docker, Docker engine-based containers, I must say, but also for more open container initiative products like kata containers and containerd, for instance. And to integrate everything from the traditional world from WebLogic Java into Kubernetes, they needed extra stuff like an operator, and they also had tooling around monitoring, Prometheus in this case, and logging for using Elasticstack. So this is how it looks like when you put Oracle WebLogic in a container. Now, a container needs to be lightweighted. That's usually the standard. But when you have a container like this, it's pretty much about 2 or 3 gigs. That's quite heavy. Anyway, if you do it on a layered manner, if you build it up in a layered manner, then you can skip out of some of the dependencies if you pull down the image from your repository. So this is how an Oracle WebLogic container is built up. So a base image as slim as possible, Linux. The JDK and WebLogic binaries, an image of the WebLogic domain, base domain, and the deployable apps which you want to have. And it all runs in a container runtime. Could be Docker, could be any other runtime container engine. Now, to work with Kubernetes, you need to tell Kubernetes what to do with all these pods and these containers running in a orchestration environment, because Kubernetes doesn't know anything about WebLogic or Java or whatever. So you need to have something in between, and operators are useful to leverage more experience-based knowledge on what the platform does. So it does know about high availability within WebLogic. It does know about clustering within WebLogic. It does know about how the JVM works. That is not for Kubernetes. If you have a VM also doesn't know what's running on top of that. You need to have your own software to run it. So I already mentioned the WebLogic Kubernetes operator is for manage your WebLogic environment in a Kubernetes environment. And it handles all kinds of stuff like load balancing, networking, controllers around load balancing for your Kubernetes cluster, or ingress controllers, restarting, stopping, starting, all those stuff is handled within this operator. And also deploying your WebLogic infrastructure. So this is how a WebLogic domain works. Does anyone work with WebLogic? One. Okay. Maybe I need to explain a little bit how WebLogic is built. You have a configuration which is called a domain, and within this domain all the configuration items are stored, in fact. And you have a repository, some XML files where all the configuration is saved. And at runtime you start up a Java container, or 3 or 4, and these Java containers are represent actually the managed servers within WebLogic. So a managed server is in fact an extension on the Java container. And within this managed server you can deploy a Java application or multiple Java applications. So in this container, this managed server container, which is actually a JVM container, all the applications, Java applications are running. And the admin server is also a Java container, but it's only for, well, as it say, administrative purposes. So the implementation on Kubernetes is that every managed server, JVM, or every admin server is a pod. So that's one-on-one. And this is a bit about the process of how to install Kubernetes on WebLogic on Kubernetes, sorry. So you create a job which creates a domain, WebLogic domain resource. It pulls all kinds of stuff out of the configuration and makes a job from that within Kubernetes. And this job kicks off a process to create a domain on file system, and it starts up the domain when it's ready. So it does some introspection in between. And after that you can manage your domain using the default command line tools or your Kubernetes dashboard, or use it with Ranger, for instance, can also be done to run your WebLogic domain. And extra, you can expose some stuff with Ingress to the outside world. If you have a console which you want to expose, or an application, you can use load balancing or ingresses to expose it. And you can also use Elasticsearch and Prometheus and Grafana in combination with the WebLogic operator to monitor your environment, which I will come to later. Already told you, WebLogic was a Java application server, and when Oracle acquired WebLogic, they lifted and shifted all the products they have on WebLogic running. So Oracle has a product which is called Oracle SOA Suite, and Oracle SOA Suite is a SOA implementation of the SOA architecture. It's already ancient. It sounds ancient, SOA, because everyone is talking about microservices now, but the basic concepts are still there, and still a lot of companies who are maybe at the beginning phase of this. Oh, here it is. So this is a SOA generic landscape. I discussed this because this is also a part of what needs to be monitored within your Prometheus and Grafana and Elastic Stack. So first of all, you have your databases and where all your data is stored. You have a segment which is called process services, where the business logic resides and where you can maybe use some kind of a low-code tool like BPM. So no modern tools, but BPM was already there for a long time. But BPM never was the promise the promise they made was never realized, that business people could create their own workflow and that technicians or technology experts will are connecting everything together. In the end, I saw a lot of stuff, a lot of things happening that the entire stuff was built by technology people, and that from that on, actually the customer didn't get what he or she wanted, in fact. So you have your data service, which is in the database, and then on top of that you have a enterprise service bus for the routing for the routing, in fact, and on top of that you have your portal for your process management and web portals. A little bit of security and monitoring and managing your infrastructure and your services. So if you look at the Oracle implementation of SOA, then you have your operating system, you have your installation, your Java, WebLogic, and SOA software installation. So it's a layered installation, just like when you have a Windows or an Apple. You can install it, but then you need to have maybe some Office software or whatever you want to run on it. So it's a layered installation. You have your domain configuration WebLogic server. You have your finally configured SOA cluster, and on top of that there are some configurations called composites, and composites are based on the server's composite architecture, which is also an open standard, where a composite is a unit of self-contained applications, and they're all autonomous, so they are not aware of anything else. So a little bit about how microservices work as well. They can manage themselves, their life cycle, everything within this composite thing. And of course, all the communication stuff like JDBC, JMS, HTTP, JMX within Java. So this is a bit about the process of how to create a SOA Suite domain on Kubernetes. You create a namespace, you create persistent volumes, you create secrets. Maybe you use secrets within another store like Helm or another maybe from Terraform, HashiCorp, Vault. There are a lot of other solutions, but for my purposes I use just plain secrets within Kubernetes. You have an Oracle database or another database to store your metadata in and create the schemas for your SOA domain. For your domain, you do the same actually. You have your WebLogic basic template and your SOA WebLogic domain templates to apply on the base domain template of WebLogic. And then you have a job running which does the introspection and finally spins up a domain within Kubernetes pods. Last for this is to mention the REST Management API. This is an interface within WebLogic for manipulating your domain through APIs. And you also can use it, of course, for logging and for monitoring that part. So the monitoring framework, first of all, a short overview of what WebLogic has for monitoring stuff, because there's a lot of metrics in there, but it needs to be pulled out. And when I lead a team of 10 engineers or so, and we have a lot of customers, or maybe 10 to 12 customers or so, and one of the customers has a performance problem. And the first thing an engineer does these days, I don't know about you, but the engineers in my team, maybe I should teach them better, but first the thing they do, they go to Linux or Unix, they type in VI, log file, and try to trace manually what's happening. And this is not the way to do it actually. There are a lot of tools which you can use to correlate everything which is happening into your system. But this is a process which everyone, also an engineer, needs to go through. So I try to help them with that and say which tooling is available already only on WebLogic, besides all the Grafana and Prometheus stuff. So WebLogic has a diagnostic framework, which is a framework is built on so-called M-beans. And M-beans are managed beans, and every bean is a component within the WebLogic domain structure, which can monitor or can manipulate an application. And you have some side monitoring plugins within WebLogic, and you also can use it for if you have a ticketing system to have a incident packaging system. It makes a package, it makes a dump of what's happening on that time when maybe out of memory error occurs within Java. Then it will be packaged into a collection of log files and a Java snapshot to be analyzed. So these are a bit of the diagnostics framework. Okay, I will skip that one because I want to talk about this in my time. So you can use the standard tooling. Another thing is you can say if a customer has a license for databases and WebLogic, then Oracle comes in and says, I have a good license for you for monitoring as well, but you have to pay for it. Maybe 8,000 euros a year. So, and then a lot of customers say, what's it gonna bring me? I have Nagios. Yeah, but with Nagios you can't monitor any SOA stack traces because Nagios is for operating system. So the customer buys it and they don't have any engineer because it's really complicated as well to configure it. A customer buys it, spends a lot of money on this monitoring packs, which they call it, and it's not being used. So that's a waste of money and a waste of time as well. So what I thought of for the customers I have, why don't we do it with open source monitoring? And this is still a path and a journey to go through because we haven't figured out everything, but there are a lot of things we've done and achieved for the customer to monitor their, in this case, their SOA stack. So the components for collecting log files out of WebLogic and do something useful with it, it's called the WebLogic logging exporter. You wouldn't be surprised it would be called like that. And the components are, of course, logstash Kibana. No additional stuff, no metric beats and so, but maybe that's for later implementation, I don't know. Of course, you have a YAML file to tell to your Logstash, or to your Logstash, sorry, what to export, which fields to export, and then you have a jar file which does the real export within Java. And for that you also need Snake YAML, and Snake YAML is a tool to parse and emit all the log files out of the JDK logging, because WebLogic uses JDK logging, or log4j if you have another implementation, to parse all these stuff out of these log files and push it to Elastic Stack. So what you need to do is, for my case, I installed the Elastic Stack with an operator in a Kubernetes cluster. I copied all the jar files to a shared location. So when I set up this WebLogic domain, I used persistent volume on NFS. So all the domain artifacts are stored on a shared volume. I have to add a startup class for WebLogic to use this special class for WebLogic for exporting all these log files. And I have to set up the configuration. So first of all, this is the class path, domain startup class, used for exporting my WebLogic logging. And this is the configuration for the Elastic Stack. And here you can see I have an index name to be indexed within Kibana later on, and some stuff about where Elasticsearch is running at in that cluster, in that Kubernetes cluster, and what to export and what kind of severity to export. And then you can go to Elasticsearch and create index patterns based on the index patterns you defined from your out from your WebLogic domain. And I've used a simple index pattern which is called WLS, but you can use anything you like, of course. And then you can see your logs appearing in Kibana. Of course, then you need to do something useful with it, like creating dashboards, or maybe do some intelligent stuff like anomaly detection or clustering or whatever you can do. I don't know if it's included within Elastic Stack at the moment. It must be a paid version, I think, because in this version it wasn't there, but I think you should do something useful for it. But another thing of doing this is this. When you have a siloed way of doing your applications and your management and your operations, the eternal discussion I get always from developers, I want to have an account on Linux because I want to see those log files, and then the operator says, no, we are not going to do that. What do you need to do on this system? And in the end, some manager comes in and says, yeah, give him a root access and do anything on it. But that's not going to happen anymore, because all these developers, testers, anyone who wants to see you get access can all see it from here. So it's a centralized repository for all the log files which are there to collect and to be analyzed and everything you want. So that's already a win for us. And next step could be maybe do some intelligent stuff with it. Now, if you look at the logging within WebLogic, there are two engines, in fact. You have the Java JDK logger, or log4j if you use the other implementation. And you have another implementation, which is Oracle Diagnostic logging. And if you have a product like SOA installed on your WebLogic server, then more application-related stuff ends up in there. That's a bit of a separation. And up to a few months ago, there wasn't really a good solution for that, but now there's a solution to get all the Oracle Diagnostic logs out of WebLogic and export it into Kibana without doing it manually, because manually, yeah, that's not what you want, of course. So you can, let me see, yeah, that's the one. You can make, within Kubernetes cluster in this case, I made a deployment in Kubernetes, and from there I put in a filter on what to pull out of these log files. So for that case, you can make a lot of correlations within your SOA application, message IDs, assets, all those kinds of stuff. You get it all in your log file analysis, and you can do something useful with that too. Okay. Next one, log file analysis. Yeah, it's more near real-time monitoring. You want to also have something real-time monitoring, maybe. So we also looked at Prometheus and Grafana, of how to set it up. Is it useful to use within these kinds of environments or not? I don't know. If you have a dashboard and you don't do anything with it, or you have a solution and you don't do anything with it. So we try to implement it. The components, of course, this is called the WebLogic monitoring exporter. You must be surprised either again. And what you need is, you need a Prometheus and Grafana installation within Kubernetes in this case. You need a WAR file, and a WAR file is in fact a packaged web application. And this web application does all the scraping within the WebLogic application server. So all the metrics which are defined in these mbeans, which I already mentioned, are getting out and exposed within this web application. Then you can create your own dashboards, or you can use some examples of JSON dashboards to import it into Grafana at the end. And a next step, which is still under investigation for us, is to also use the DB exporter deployment, because the SOA technology from Oracle uses a lot of state and a lot of metadata of all the running processes within this SOA transaction. So all these states, and these states can be running, faulted, error, everything. We want to see those also in our dashboard. First of all, the setup for Prometheus. You have the WebLogic Diagnostics framework with all the metrics already there. Then you export it by using this WLS exporter web application, and all the metrics you define are exported into a web application, in fact. But that's you don't use it for the rest. It's only for feeding Prometheus with all these metrics. And then in the end, of course, within the Prometheus data source, you can expose it into a dashboard, into Grafana, visualizing it. So the integration is to generate all the export awards for all the managed servers, to get all the mbean metrics out of it, deploy it, and to integrate it within Prometheus, you have to create a role binding and a service account using a YAML file which defines which roles it needs to have, and what needs to be labeled, which domain, for instance, and which application should feed Prometheus with metric data. And in the end, you get the Prometheus, within the Prometheus console, you can see all the metrics which are exported from the WebLogic web application into Prometheus. And finally, you can, what I already mentioned, you can import a WebLogic dashboard. You can also configure some stuff yourself, like when you have a WebLogic server which has a certain state, can be running, can be failed, can be down, then you want to have that state somewhere, and you can grab out of the metrics which are gathered by Prometheus. You can grab out a metric like WebLogic server state value, and you can map them within Grafana into some values, and these values represent a number, and this number can be mapped to a text. and the text matches what WebLogic has. So if you have shut down or failed, then you can see that in your actual dashboard at the end. And this is then a dashboard within Grafana, which is running a SOA Suite server. So you can see the heap usage, the stuck threads, and stuck threads are in fact WebLogic/Java threads which are stuck in their work. It's not an error, but it's more like when the database is not responding or has a slow response time, then the application tries and tries and tries, and the thread which the application is doing its tasks gets stuck, and that's a diagnosis within WebLogic which you need to solve. So a lot of other possibilities are that you can use the SOA dehydration tables, and dehydration tables are in fact in tables within the database which holds the state of all the SOA transactions. In fact, I already told you. So what I've used is a database exporter to export all the queries which are related to SOA transactions into configurable metrics for Prometheus and Grafana. So what you can do then, for instance, if you have a SOA instance running, it can sometimes run for a long time, maybe for a month. Within the Rabobank I had an application which is called moving. Customers were moving from one address to another address, street address or a city, and this could take a long time. So this in between, this customer still was on the move actually. So this was a long-running Beeple instance. So this needs to be monitored every time if it's still there, and if it's finished, then it is completed or a status faulted or any other status. But it can run for a long time, and also translated into Java, it's also a Java action within the JVM, which is running for a long time. So also within your JVM, you need to have a good garbage collection, and you need to have a good cleaning strategy. So all this stuff needs to be monitored as well. And one of the benefits in this case was also that we didn't need to buy the commercial Grafana plugin from Oracle, because this one is licensed again. So this was a solution which spares us a lot of money. So this is a flow of how it works, more or less. I don't know if you know anything about SOA and how it's built up. SOA is in fact a combination of Enterprise Service Bus and an execution language. Enterprise Service Bus does the routing and everything, but if you need to enrich your data from other sources, then you can use BPEL, because BPEL uses a lot of steps, and BPEL stands for Business Process Execution Language, and from that on you can pull something out of this system and pull something out of that system, and all together it creates a payload, an XML payload in total, which you can have for your final SOA transaction. So all these steps, these activities within such a BPEL instance creates a dehydration point, and this dehydration point is stored in the database. And such a dehydration point is like having an action or a status running or a status waiting, or those are dehydration points. And to monitor these, you can say, well, I use a commercial product to monitor it and configure it, and spend a year or so to figure it out. Or you can say, well, I type in SQL Plus into my database and I select everything I want to know and I export it to an XML or Excel file or so. But that's also useless, of course. You don't want that. So for this, we figured out of how to do this with a database exporter. So this database exporter makes use of a TOML file, and in this TOML file you can define all your queries you have. here in this query all the states which are possible within a SOA infrastructure. And with this TOML file you can make metrics which can be applied to your Prometheus. And all these metrics then are imported within your Prometheus and Grafana dashboard at the end. Using this DB exporter, of course. There are still a lot of open ends. It's not complete, I admit, but this is a good start for a lot of customers now to have a good vision of how their SOA infrastructure, how their WebLogic, how the Java applications are doing. So these are some open ends. It's just there are limited support, limited features for a lot of MBeans. You have a few of them, so like the JVM runtime, you can monitor everything of your JVM runtime, like how many heap it's using, how many percentage. But you can also look at stuck threads, for instance. You can also look at your database pooling, JDBC pooling, your messaging, JMS, because within a transactional environment like SOA it uses a lot of messaging within JMS. So you can use it for a lot of stuff, but if you have application-defined MBeans, if you want to monitor anything specific in your enterprise Java bean with an MBean you built yourself, there's no support for that, so you have to figure it out yourself. And what I'm still looking for is more use cases to use it in Elasticstack, only then make it as a portal for developers or other stuff who are not operating and doing live stuff. Okay, that's about it. If anyone has questions. Thank you very much. These are my socials, but I will publish this presentation to the organization, and you can read it afterwards as well.
Any questions? Just raise your hands. None? Well, then I would say thank you again, and have a nice coffee break outside.
Yeah, thank you.